Today we are going to be talking about policy-based infrastructure as code alongside Kyverno. So my name is Shivam Tyagi, and I'm presenting alongside Kumar Arjun. We both are participants of the Nirmata team, and today we're going to start with the basics, like what exactly is a policy. First of all, let's give a brief outline of what the talk would look like. We would be talking about the backgrounds of policy management and alongside infrastructure as code. That would be followed by what exactly Kyverno is and where Crossplane stands, followed by a merger of how we can use both of them together, and with a short demo of our what we have to offer. And yes, if you have any questions meanwhile, you can please raise your hands and interact in between. So moving on to what exactly is policy. So policy is defined what exactly is allowed and what exactly is not allowed on a singular cluster. Talking about, like, if you can just see on the right hand side, there is a simple message where the latest tag is not allowed. This is helpful when in the production environments where you have to work with a stable version rather than going for the latest tagged image. So that is how a policy is structured around, like what is allowed and what is not. The main reasons why policies are important is to enforce security, the compliance, and the best practices that are out there. Now, anything that is related to policies is supposed to be implemented or enforced via something known as policy engines. The most popular ones are Kyverno and OPA and JS policies. Now, what exactly the policy engines do and how they are implemented, that is something we would be learning later on the talk. Next up, okay, before moving on to the details of the talk, a small introduction about the infrastructure as code and where does the need for infrastructure as code arrive from. That would be when, as a developer, sometimes it happens that we need to have a particular resource over and over again, and that causes the platform teams to build the entire infrastructure either from the scratch or from a basic level. That just adds onto the extra work that is out there. So to manage all those infrastructure issues, to address all those issues, infrastructure as code was introduced. That is accomplished via the help of certain tools. The popular ones are Terraform, Crossplane, and Pulumi. We would be briefly talking about Crossplane in this talk. In the right hand side, you can see, like, a developer first writes the infrastructure as code, and it's a suitable practice to implement the GitOps principle while implementing infrastructure as code. So this is where the version control system talks to an API server, and that is in turn implemented as infrastructure as code. Later on, what exactly are the advantages that come alongside with? So one of the popular ones out there is the cost reduction, and important one to figure out here is whatever is written out as code, it does not edit out of it. It's like that's where the last pointer, that it eliminates any configuration drifts that is available out there. Also, it increases the speed of the deployments and improves the infrastructure consistency meanwhile. Now moving into our project, that would be Kyverno. And Kyverno is a very popular and high in demand project that is CNCF incubating at this point, and the main highlights of this particular Kyverno would be it uses simple YAML-based policies and it's Kubernetes native. What exactly would somebody mean by Kubernetes native is that it is designed to run seamless work seamlessly with the Kubernetes platform, and any resources that we define that follows the standard Kubernetes format that is out there. Now, you can also integrate the Kubernetes resources. These are what the already available Kubernetes resources that are out there. It works seamlessly with them. On top of that, Kyverno also works very well with the custom resources, and it is one of the most starred Kubernetes policy engine on GitHub at this point. It allows integration with CI/CD pipelines so that the entire software development comes in a very harmonized way. And let's say you know what the report generation, that is also one of the features of Kyverno, and the statistics that are currently something that is quite impressive at this point is it has got 3.9 K stars on the GitHub and has about 1.6 billion image pulls. And next on, yes, Arjun would like to continue from this point.
Okay, so if Shivam hadn't bragged already, business is good for Kyverno. Next.
Yeah.
This is what the Kyverno policy on the right would look like, but let's discuss the use cases first. So a popular one is pod security. So pod security standards were deprecated starting 1.2.5. So how would you enforce those granular permissions now? Kubernetes suggests that you use something like Kyverno or OPA, standard policy engines, to do such granular control. Over pod security, there's also multi-tenancy. You can have namespace provisioning, that is, you decide what namespace is allocated to, let's say, which team, and what are the permissions over them. You can granularly control what resources they can create, they cannot create, and so forth. Then you have your supply chain security, which is a major use case here. You can do your image verification and ensure that the images that are being deployed on, or even the manifests that are being deployed on your cluster, are secure. But we'll see going forward, since we are talking about IOC with Kyverno today, that this goes beyond Kubernetes itself. We'll talk about how it looks like in the cloud. And then we have the fine-grained RBAC that so you can even control to what extent, or let's say even the name of the resource that's coming in, or it has certain labels, then what RBAC it should follow. Then you have sidecar injection. So often you'd want that, let's say, whenever you're deploying your MongoDB, you inject a sidecar with it. So in that use case, what you'd do is you'd use on the right, you'll see there are 4 types of policies that I've listed down. And one of them is generate resources, and the other is mutate. So in the case of injecting a sidecar, you want to edit the deployment and insert a new container there. So you'd use a mutate resource, or you'd use a mutate rule, that is you mutate that deployment to have a new sidecar. Okay, and but let's look at this from a basic perspective. A policy, as Shivam said, it's a set of rules that define what can and cannot be done. And in that, you have, first thing you'd like to know, how do you identify those resources? So we have the match and exclude blocks here, which basically help you filter out those appropriate resources, and then the rule types. So first, I gave an example for the mutate resource with deployments, and then you have verify images. That comes from the supply chain security. You can verify which images are running on your cluster. Actually, it's not even just limited to images. You can have any OCI artifact that you can verify. And it's you can also basically validate. That was the first policy we showed. We validate whether the image that is being deployed is a stable image running with a stable tag, or it's a latest image. and then we have generate resources. So whenever, let's say, you create a namespace, then you may want to automatically provision or create a new resource inside it, so you can generate a new resource based on the incoming resource. Any questions so far? Order of exclusion, not really. So you can just say asynchronous.
So it can go in any order, like muted resource will be executed before validating.
Oh, no. Oh, not in that. So if you go to the last slide, in the appendix. Last. Go. Yeah. So this is what the admission review looks like. Okay, so you see first is the mutating admission. That's where you do all the mutations, and then comes the validation. So I think that's your question, right?
Yeah. Hi, this is Prajwal. So in the OPA we do have this, we'll be writing a piece of code for the Rego, right? Like to govern your cluster and the constraints. So how does things takes place in this Kyverno?
We write YAML. We don't write Rego.
Yeah, but whenever it comes for the custom policies, I do want to control, right? Will that supports everything
custom
in the
policies in the sense?
like let's say if you do not have any use case, like let's say if I want to restrict the stateful application sets in a stateless cluster.
Yeah.
So that kind of custom things if I want to control.
Obviously.
Okay.
So that's what we had in the match exclude, right? You write your own policies. There's no specific. There is not only a set of policies you can use. You can write your own. Right?
Thank you.
Okay. Now that we have talked about it, let's look at Kyverno's operational scope. On the next slide. So we in Kubernetes we have these. In the cloud native space we have these 4 C's called code, container, cluster, and cloud level security, right? So with Kyverno, if you are running it along outside and along with, let's say, an IAC tool such as Crossplane, then you are able to control basically all 4 of these aspects. So how you write your infrastructure as code. So in a way you are ensuring that your code, you are basically writing policies for that code to ensure that those YAMLs are appropriate and they are permissible according to your standards. Then you have container level security where you can do the verify images rules. You can apply those. And then you have the cluster level security, which is out of the box since you're running Kubernetes, Kyverno on a Kubernetes cluster. And then you have the cloud level security, because with IAC now you're governing what IAC would do and would not do, right? So you have all 4 covered with Kyverno if you use it with an IAC. If you use standalone, then you can cover container and cluster. Code level also to some extent, because you do YAML signing and verification as well. So you control manifest supply chain as well. Okay, now on to Crossplane. So Crossplane is also a very interesting project, and it's very similar to Kyverno in these ways, that it's a CNCF incubating project. Its resources are also YAML-based, and it is Kubernetes native as well. It has several providers out there, popular ones being AWS, Azure, GCP. We'll be using the AWS one in our demo. And we have, so how does Crossplane work? So Kubernetes has this construct of controllers. So when you define a resource, you can, based on that resource, you can control what happens, or basically when you define that resource, that there's the reconciliation based on that resource, or any routines that you run based on those resources. In the case of Crossplane, these routines being provisioning and maintenance of your infrastructure. And it's not just the existing controllers, you can define your own compositions based on the existing Crossplane resources. So you can provision these controllers on the fly, and just by writing YAML. So it's very interesting in that sense. And since it allows the abstraction of these compositions, and you can put them together. Let's say if I want to, every time I want my developer asks for a database, they are also asking for an associated S3 bucket, and that's a use case with me. So I can create that composition so that that developer can self-provision, and that way I'm abstracting out all the details, hiding it from my developer. And then since we are doing abstraction, it becomes easier for us to do policies and security as well. Next. About the self-service model, as I mentioned, Crossplane has these compositions. So like in the graph you can see, here you as a platform builder, you hide all the details of the provisioning from your developer. And your developer just has to create a claim or claim that type of composition. And in the diagram, you can see it's, so a composition is a one-to-one with a composite resource definition, which is similar to what we have CRDs in Kubernetes. So you have CRDs in Kubernetes that define your custom resources. You can define custom compositions with this. But I'm not going into too much of detail on that. And so that's, we talked about compositions, and the example being you provision your S3 bucket, let's say, along with your database. Next. Okay. How does the self-service model look like, and how does it internally work? As a developer, you would ask for a certain resource using the YAML manifest and using that schema that would go to your Kube API server. In this case, you can see you have this management cluster. I'm calling this as a management cluster because Kubernetes here is acting as a control plane for your cloud infrastructure. On the right, I have my cloud service, and that I'm controlling with Kubernetes. So when I have that S3 bucket resource coming in, it goes to the Kube API server, and then from that, it goes to Crossplane. And then the Crossplane controllers create your provision, your resource accordingly. So in this case, an S3 bucket. Next one. But where do policies come in? How do you, I mean, basically in that way, your developer can provision anything they want, right? As long as they know the manifest. So, or they have RBAC even, but how do you granularly control that? And how do you ensure that the best practices are followed both at the platform level as well as the developer level? So, as a platform engineer or an SRE engineer, you would want to have some policies on your cluster. Defining what can and cannot be done, much said. So with the developer, so when the developer in this case wants to go through the S3 bucket and create an S3 bucket, this request would first go to Kyverno. So Kyverno would validate based on these policies whether this action is permissible or not, and whether I should provision that resource. And then it goes to Crossplane. So we saw the last diagram where we had the mutation webhook and then the validating webhook. So this webhook ensures that your policies are followed, and then you finally provision the resource if the resource is, incoming resource is compliant. Okay, any questions before we go to the demo? So for the first demo, I have a very simple policy, and what I'm going to do with this policy is make sure that the bucket I'm creating is limited to the US West 2 region. Okay, let's map this to our policy schema first. So you can see that inside match, and this match is looking for the bucket. So this bucket is a Crossplane resource, and then I'm looking for that resource only, then the name of the rule, and then the validate block. So this is the validation, and on line 14 you have a message. This is the message that's being printed out or audited when that violation is encountered. And you have the pattern. So this is the pattern I'm looking for in that bucket resource object. Okay. So in this case, I'm just looking for the US West 2 region, and that's about that. And then the validation failure action. So this ensures that in which mode should this policy be applied? Should it be an enforce mode or an audit mode? What that means is if you're running this policy in enforce mode, then if that incoming resource violates this policy, then you don't let it go in. The validation admission webhook would reject this resource, and therefore it would not be created. If it's running in audit mode, you let the resource be created, but you make sure that you have an event logging that. And this event, so we also have policy reports, which also which would log this as well. So let me create this policy first. Okay, looks like I got logged out. All right, let me play the demo videos for you then.
I have one policy and include doc and then these rules, rule definitions themselves.
By the way, can you hear the audio here? Can? Okay.
This is the message that's this path spec push that it
I've just done the same thing, created that policy.
Okay, so looks like the policy is ready now. Now I'm going to admit two buckets here. So the first bucket is declared for the US West 1 region and the second bucket is for US West 2.
Sorry, the audio is not clear. Maybe you can mute it and talk through us.
Okay, yeah, that makes sense. So in the after I created that policy, I'm showing you two resources here. One is declared for the US West 1 region and the second one's for US West 2 region. So US West 1 is not expected to be created since it's that violates the policy. So when I try to create that, you see this message pops up. And it says that this location is not allowed. This is the same message we wrote in the policy. And then you have that resource blocked. Okay. So when I try to create the second bucket, however, then it goes in. The bucket is allowed to create it because it follows the policy. And I'm just listing the policy buckets here. So you see that the second bucket was created, but the first one was not. When I refresh that, you see the second one is created, not the first one though. Okay, and after that, I'm going to show you this. Right now, we were running in enforce mode, so how audit mode would look like. So I've just edited this cluster policy and set it to audit mode here. Now when I create the first bucket, since in solid mode, we are not enforcing that policy. So that bucket is created. And this CPOLAR stands for Cluster Policy Report. And as I mentioned, in Kyverno can generate those reports. These reports are standard WG policy, follow the standard WG format. So you can, let's see the schema. Yeah, so this you see is the standard policy report format. You have the results, the category message. This is the message again, the one we saw, the violation. And then you have the policy. Then the resource information. It was a bucket, demo one bucket, and the result that is failed since it was not allowed to go in. And you have the specific rule which was violated. And that's so more info on that. Severity, source, all this. So the other metadata. And here you'll see the first resource is set for result fail, but the second one's pass. So the pass one is the one, this VS West 2 region one, and that was allowed to be created. So that's a pass one. Okay, now I'll go to the second demo. Any questions on the first one? First one, sorry? Because it was created for US West 1 region, right? And then in my policy, I was only allowing it to be created for US West 2. All other regions I was supposed to reject. That's why.
Okay. Okay, we are running a little late. Maybe we can share the demo later and we can wind up at this point.
Yeah, okay. Yeah. Okay, yeah, I can do that. It's only a couple of minutes though, okay. The second demo.
Thanks.
All right, so I'm just gonna quickly go with the second demo then. In the second demo, I'm doing a image verify policy. So I'm basically your AWS has these jobs, and jobs follow these job templates. So you are provisioning containers to run when the job is provisioned, right? So I'm just going to verify that that job is running with a good image being the one that's signed with the appropriate private key. So this is what the policy would look like. It would have this verify image rule and the associated public key which I'm supposed to check for, and this path which is supposed to extract this image from the associated job definition resource. And then when I try to create using a signed image, it's expected to be created, then the unsigned one is not, and that's what I've just quickly showed here. So the unsigned one, when I'm trying to create, you see it would be violated and it would not be created. But the signed image, the expected one, would be created. Let's quickly do that. Okay, the second one I've just changed it to signed, the image, and then I've verified here that it's created as expected. All right, to wrap up, so Kubernetes security is important. You can run your cluster however you want, but if you don't have security, then you'd run into you would be running into N issues, and then basically recovering from those issues costs more than having your guardrails, your policies firsthand. And in this case, we talked about IAC. So with IAC, you can basically control policies or have best practices not just on your cluster but on your infrastructure as well, combining Kyverno and Crossplane. And that's about that. Thank you. You can join the community. There are some links here. You have your Kyverno policies and the playground. This one's a really cool tool. You can do dry runs for Kyverno policies with custom resources as well. And then I have the other links as well, so you can check them out. All right. Thank you. I think